Alright, here we go. We got Unit 9 here. We are starting our three-dimensional figures unit. So the first thing here, we got a couple of vocab words here. So polyhedron, this will be a solid three-dimensional figure with multiple faces. Okay, you're also going to have a net, which is a polyhedron that is unfolded. And another thing you could write down is maybe a two-dimensional representation of a three-dimensional object. So like for example, if I have a cube drawn and I wanted to unfold that shape and see what it would look like, this is the net that you would draw for it. So that when you folded your net back up, it would fold back up into a cube. And there's not one way to do the nets for all of the different shapes. You know, sometimes there's variations of them. You just want to make sure that it would fold back up into the shape that you're dealing with no overlapping sides. Okay, so today is more about the cylinders, and then we'll probably do a little bit of the spheres with it as well. So first, a couple of formulas right here. So the lateral area of a cylinder. First of all, here's what a cylinder looks like. That's a circular shape. And you know, it's kind of hard to do here and make it look pretty on Notability, but there you go. That's kind of what it looks like. So it's a circular object with you know, a circular side going up and down. This circular side going up and down right here on the outside, that is the lateral area right there. And the way to find that is either do the circumference times the height, but most of your formula charts are going to say something like this: 2 pi r, and then times h right there. The 2 pi r, that's the circumference part, and then you multiply it by the height. Now, as far as getting the total surface area, you're going to have to add on the areas of the bases, and you have two of those. So you're going to do the circumference times the h again, but then you're going to add on 2 of the bases right there, and I'll use big B to represent the area of the base. Now, most of the formula charts are going to have something probably more, you know, written out. So there's the 2 pi r h right there, that's the ch, and then the 2 times the area of the base, and the base is a circle, so we'll say 2 and then pi r squared right there. And that's probably the formula I'll plug into quite a bit today, but it comes from this stuff right here. Alright, and then volume is going to be the area of the base times the height. So that'll be the area of the base is pi r squared. So then you'll just take that and multiply it by the height. And just keep in mind that volume is going to be cubed units, and then total surface area or surface area, those are going to be squared, some units there, and lateral area as well. So as far as the net goes for a cylinder, if we unroll a cylinder, you're going to have this rectangular shape for the sides. That would be like your lateral area piece right there. And then you'd have 2 circular bases. Hopefully they should be the same. And then when you fold it back up, it should roll all the way back up into that cylinder. So we're going to go ahead and try a few of these here. And just for time's sake, I have all the numbers and everything already worked out here, so I'm just going to kind of copy that over. Now what your teacher will probably want to see is the formula and then see the numbers plugged into the formula. So like for the lateral area, it's 2 pi r h, so we're going to go 2 pi, and then the radius was 3, and then the height going up and down is 8. And what you got to get in your head too, the height of the cylinder is always the distance between the bases. So we'll say the distance between the bases. Okay, so then when you punch all of that out there, you're going to get 48 pi, and then we'll say, I guess, meters squared right there. And actually, most of the times in this class, we're going to leave our answers in terms of pi, unless it's like a word problem or maybe it says otherwise. So that's your answer there for that. Now the surface area, you do the 2 pi r h. So you take that 48 pi, but then you're going to add on to it. So we'll take 48 pi, but then we'll add on the 2 extra bases, so 2 and then pi r squared. So r, what was that, 3 again, I guess, so 2 pi, and then, so that'll be 9 times 2 right there, that'll be 18, you add that up, that'll be 66 pi, and then we'll say meters squared. So it's a lot of plugging into the formulas. So you need to know your formulas and then check with your teacher whether you're supposed to have the formulas memorized or if you will be given the formulas on the test. Okay, volume, formula for that, pi r squared, that's the area of the base, and then times the height. So then we'll do pi and then times 3 squared and then times 8. That'll get you 72 pi and then meters cubed this time. And those are all of your dimensions there. So lateral area, surface area, volume there. One thing to keep in mind, the volume number sometimes will be a little bit bigger than the surface area. Sometimes it can be smaller though, because they are 2 different types of units. One of them is square units, one of them is cubed units. So they're totally independent. Every now and then, sometimes they'll be the same. One might be bigger, one might be smaller. So, but it's not going to be like some consistent pattern. I guess when I was in high school, I always thought volume was going to be the bigger number, and that's not necessarily true on every one. Okay, so let's go do the same thing for this one here. Now notice with this one, they give us the diameter. So that means your radius equals half of that length right there. So your radius is actually going to be 9 right here in this case. So you got to be kind of careful when you're plugging it all in there. So 2 pi r and then h for lateral area. So we'll go 2 pi and then the radius was 9 and then the height is 5. When you punch all that out, you should get 90 pi meters squared. Remember, we'll leave pi in our answer. If you wanted to get the decimal answer with this, you could go take your calculator and do 90 times either 3.14 or you can do times the pi button. And that does give you approximately, those little squiggly lines, if I draw them nice, that means approximately 282.6, and then I guess meters squared. So that would be your decimal that goes with it, but once again, we'll probably leave most of our answers in pi today. Okay, surface area, you can do that one, so that'll be the 2 pi RH, and then add on the 2 pi r squared. So you take your 90 pi, and then we're going to add on 2 pi, and then the radius was 9, so 9 squared. So it'll be 81 times 2, and then you'll add all that up. And whenever you do that, you get 252 pi and then meters squared. But I would definitely practice, typing that in and making sure you're getting the same things. Okay, volume, that's pi r squared, and then times the height. So r, that was 9. Height, I think that was 5. Yep. And then you punch that out and you get 405 pi. And then it'll be meters cubed there. And that would be your answer. Alright, so where it's a little different, you might have done that a little bit in middle school. Where it's different is actually going backwards and solving for like an unknown dimension, so like the height here in this case. Because in this example, they give us the answer of the surface area right there. So it's 198.8. So we'll go 198.8. And actually, you know what? Before I do that, I'm going to write out the formula for the surface area. So that's 2 pi r h, and then plus the 2 pi r squared. And then what we're going to do is just plug in everything we know. So we know the surface area is 198.8. We know that the radius was 2.8. Alright, and then we know also over here that the radius squared is just 2.8 squared. Now, since my final answer doesn't have it in terms of pi, like they didn't leave pi in the answer, we're actually going to take these pi's right here and we're going to use a decimal for that. So we're going to use those as 3.14 for both of those. And you can use the pi button. It might get you a slightly more accurate answer towards the end. So it doesn't matter necessarily there. So anyways, so right here we got, oops, forgot my h there. You got all this stuff times h. So what I'm going to do is use my calculator to multiply all the numbers in front of h right there, because that'll be like the coefficient. And that apparently is going to get us 17.584. And then we'll just put the h there. Now all of these numbers, there's no variable there, so that'll just be a plus some random decimal number. So that'll be a 49.2352. And I'm not going to do too much rounding until the very end. So 198.8 over there on the left-hand side. So now we're just trying to get h by itself. It's just an algebra problem with a bunch of decimals. So we'll subtract this 49 from both sides. When you do that, you do get 149.5648, and then equals the 17.584h. And then go and divide both sides by the 17, and you're going to get h equals 8.5. And then I guess the units, I think it was in millimeters. And that is your height. So that's working backwards there. Not the prettiest of examples because it has a lot of decimals. Okay, this one here, find the lateral area, total surface area, and volume of a cylinder with a diameter of 5 and a height of 8 meters. So this one's just like the ones above, except they didn't give us any picture. So we'll go lateral area is 2 pi RH. So we'll go, oh, by the way, the radius is going to be half of 5, so that'll be 2.5. So when I plug that in, that'll be 2 pi and then 2.5, and then times 8. Whenever you punch that all the way out, you get 40 pi, and then I guess it's in meters, so meter squared. And that is your lateral area. Now your surface area, you take that number, you take that 40 pi, and then you add on your 2 pi r, or 2 pi r squared. Yep. So that'll be 2 pi and then 2.5 squared. Alright, and that, I think that's going to get us 12.5 over there on the right hand side, so that'll be 52.5, and then pi and squared. And then volume, or wait, I don't need an a there, so yeah, just volume. That's going to be your pi r squared times height. So that'd be 2.5 squared and then times the 8. And when you punch that out, you'd get 50 pi and then meters cubed. So here's a good example where the volume is actually a smaller number, but remember it's totally different units. So sometimes that'll happen there. Okay. Number 5, this is another one where we need to work backwards here. Notice they give us the volume of a cylinder, they give us the height, but they didn't give us the radius. So we're not quite sure what that is. And then they're asking, go back, I guess, and find the total surface area. Now it's going to revolve around this not knowing the radius. So what we need to do is find that radius. So we're going to take the volume formula. We're going to say volume equals, and then pi r squared times height. And we're going to plug in what we know. We know the volume's 18 pi. We know the right hand side, you got pi. We don't know what r squared is, so we'll just leave that as r squared. But then we do know the height. And what was that? 2 meters. And that's all the stuff that we know. Now here's the weird thing that's a little bit different than the problem 2 problems ago. Notice the volume, they give us the answer in terms of pi. So that actually means you can go cancel out your pi's on both sides by dividing by pi. And that'll cancel them out. Now since you have this 2L here, we can also divide by 2 at the same exact time. And we can say, well, 18 over 2, that's kind of like having 9. And then you have r squared by itself, so we know 9 is equal to r squared. If you remember from Algebra 1, you'd square root both sides. And you say r equals, and then technically you got to say plus or minus 3. But in geometry, we don't deal with negative distances. So we can go ahead and scratch out that negative, and we can just say r is equal to positive 3. Okay. Now that's not actually what they are asking for there, because they are asking what's the total surface area. So we need to go and use that formula there. So for total surface area, and sometimes they'll say surface area, sometimes they'll say total surface area. Usually that's the same thing, or it's implied to be the same thing. So we'll go back and do 2 pi RH and then plus 2 pi r squared. So the 2 pi RH, that's just 2 pi, and then times the 3 that we just got, and then times the height 2, and then 2 pi r squared, so that'd be 3 squared. Okay, and then whenever you punch that all the way out, you're going to get 30 pi in the meters cubed for your surface area. So a lot of number crunching in the formulas. Number 6, I'd put a star next to this one here. This is kind of a classic question right here. Find the volume of an object with a hole in it. Okay, so the whole idea here, we have a cylinder, and you have like this big part of your cylinder, and then you have this smaller part right here with a different radius. And I guess the whole idea is there's a hole here, so we need to take away something right there. So we are going to subtract some volumes here. That's the whole idea with this one, is if there's something missing, subtract it. So either subtract the volumes, in this case it'll be volume. Sometimes you'll have some surface area problems like this where you need to subtract. Another thing they try to throw at us here, notice that they give us the height, the distance between your bases. They give that to us in meters. So I'm going to go ahead and convert that into centimeters. That'll be 800 centimeters. So that's just 8 times 100, 100 centimeters in 1 meter. And then now we can go and find all your volumes. So the way I kind of classify this, I'll say the volume of the large part of your cylinder and the volume of the small part of your cylinder, and then we're going to go back and subtract the two. So we'll go ahead and punch that out here. So the volume of the large, we want to use that radius of 7, so we'll go pi, and then r squared, so 7 squared, and then times the height, which remember we changed that to 800 centimeters. And whenever you punch that all the way out, you're going to get this kind of a large number, 39,200. And we're going to leave pi in our answer. Alright, the volume of the small one, we will go back and we'll use the other radius, so that'll be 3 squared, and then times the same height, so times 800. And then that comes out to, I think, 7,200. And then with the pi. And then we'll take those two volumes and then we'll subtract them. So I need my pi minus 7,200 pi. So subtract those off and you get 32. Wait, did I forget? Oh yeah, I forgot a number here. There we go, 39,200. So then whenever you subtract them, you get 32,000 pi. And then if you multiply that by 3.14, you're going to get 100,000 and then 53 or 531 and then centimeters cubed, I guess, since it's volume. All right. And that's because they asked for it in the nearest cubic centimeter. Most of the times it makes sense on those word problems to go ahead and not leave pi in your answer. So, okay, let's see here. The surface area of a right cylinder is 12 pi, and then if the height is 5, find the radius. Now, actually, you're going to have to use kind of a complex technique from Algebra 1 here, so you might need to review on that, but kind of talk about it as we go. So you have surface area. It's 2 pi RH, and then plus 2 pi r squared. And then we're going to plug in what we know. So we know the right-hand side, you have 12 pi, and then equals 2 pi. And then we don't know the radius, so I'll just leave it as r, but then we know the height is 5. And then 2 pi r squared. And then I'm just going to clean this up one more step here, so I think that's 10 pi r, and then plus 2 pi r squared. So this kind of looks confusing here at first. What we're going to do, since everything's divisible by 2 and divisible by pi, we're going to go ahead and divide everything by 2 pi. That's actually going to clean this thing up quite a bit. So the pi's cancel out. You're going to have 6 on the left-hand side, and then you're going to have 5r on the right-hand side, and then plus, and then the 2 pi's cancel out, so you have r squared. Okay, now this is actually what we call in Algebra 1 a quadratic equation right here. You have an r squared and a regular r right there. So we consider this a quadratic. And one of the techniques of solving a quadratic is solving by factoring. So if you need a refresher on that, you can go on YouTube and find 150 videos on that. So solve by factoring. So to solve by factoring, what we need to do is subtract the 6 from both sides. We need the left hand, or one of the sides, we need it equal to 0. And then I'm going to rewrite it in this correct order. I'm going to write it in descending order. So the biggest thing, we're going to do the r squared first, and then the next power of r is just regular r to the first. So we'll go plus 5r, and we'll go minus 6. Okay, so I just rearranged the order there, and also move the 6 over. Okay, so the whole idea with solve by factoring is we want to try and write this in its factored form. So this is like undoing the FOIL process that some of you guys learned here. So essentially all you need to do is figure out what multiplies to negative 6 and then adds those two numbers, add up to the middle number 5 right there. So that'd be positive 6 and negative 1. Well, multiplies to negative 6 and then adds to 5. And then if you were to FOIL this thing back together, you'd get it back up here to the r squared plus 5r minus 6. Okay. So then the whole idea with factoring after that, if you have something times something else equals 0, then you have two different cases. Either that first part is equal to 0 or the second part is equal to 0. So you're going to split it up into two cases, and then you are going to solve from there. You're going to say r equals negative 6, then r equals positive 1. Okay. And then after that, only one of those answers is a true answer. You can't have negative radii, so we call that an extraneous solution. So maybe we should write ourselves a note here. Can't have a negative radius. So r equals 1 right there. So this whole thing here is all about solving by factoring. So if you need a refresher on that, go find some other videos on that. So that one's a little complex there. That's probably as crazy as you can get there. Now, the last thing we'll talk about here with cylinders is the cross-section. So a cross-section, it doesn't even have to deal just with cylinders. A cross-section is the intersection of a plane and a 3D object. So here's a couple of pictures of what a cross-section looks like. So here's a plane right here, and imagine if you cut a cylinder horizontally, you'd get this intersection right here. So the intersection, or the cross-section, is a circle there. Now, if you had the same thing going up and down like this right here, you'd have a rectangle going on. It's just the intersection where they intersect at. If you did like kind of like your plane, I guess, going down in diagonal, it'd make more of an oval shape. It's still circular, but it's probably a little bit more stretched out, so we'd probably say like an oval. So that's what a cross section is. I think you have a few in the homework like that. So now we'll flip on the spheres. Okay, spheres, these are pretty straightforward, because in the formula there's really only one thing that can really change about the sphere, and it's just the radius. So like imagine you have a radius. They're kind of hard to draw, but you know, yeah, it's really hard to draw. I guess like sometimes we'll draw like a little circle like that just to kind of give us some perspective here. But there's your sphere. The only thing that changes is the radius. So there's only one thing that changes in your formulas. It's the radius. And as far as where the formulas come from, I think it's pretty heavy on the calculus. So you just kind of have to take my word for it as far as what the formulas are. But there they are. 4 pi r squared for surface area, and then volume is 4/3 pi r cubed. And notice you don't have a lateral area or a surface area, because really, like with the sphere, you kind of see everything at the same time. There's not like spots you see and then the top and bottom. So there's really, yeah, there's not a top or bottom. So it's just, we consider the surface area just the total surface area the whole time. So here we go. Find your surface area of this figure right here. So we're just going to use your two formulas, 4 pi and then r squared. So that'd be 7 squared in this case. And then whenever you punch that out, you get 196 pi. And then I think that was in centimeters, so centimeters squared. And then for volume, this one doesn't come out as clean because of the 4/3 part. But you can go 4/3 and then pi and then times 7 cubed. And whenever you punch that out, there's kind of two different ways you can leave your answer. You can leave it as an improper fraction, depending on what your teacher wants to see. Or, here's kind of what I prefer. I like the 457, and then if you type in the calculator, it'll say like 457 and then 0.3 repeating. So I know that fraction right there is 1/3, so I'm just going to write 457 and 1/3, and then pi, and then centimeters cubed. So any of those answers, and that would be good right there for your volume. Okay, find the surface area and volume of the given sphere. Leave your answers in exact form in terms of pi. So, and then notice here that the radius is actually 3, which actually makes our numbers, they're going to clean up really well. Whenever the radius is something that's divisible by 3, usually things clean up pretty well. So we'll plug in that 3 squared right there. That's going to get us 36 pi, and then I think it's millimeters, so millimeters squared. And then volume, that'll be 4/3 pi, and then 3 cubed. This is almost one you can do in your head right here. That's 27, and then 27 divided by 3 is 9, and then 9 times 4 is the 36. So actually, this is a really strange case where the numbers actually come out to the same right here. It's 36 pi and 36 pi. But remember, you have different units. One of them's in meters squared, and the other one's in meters cubed. So one of them's a 2-dimensional unit, one of them's a 3-dimensional unit. Okay, last one here on the sphere. This is kind of like the cylinder problem where we need to work backwards here. So the surface area is 110.25 pi. So that's equal to our 4 pi r squared. And then the whole idea is, hey, let's get r squared by itself. And just like that previous problem, we can cancel out the pi's just by dividing by pi. But then at the same time, we need to get rid of that 4. So we're going to divide both sides by 4. Whenever you do that, you get, 27.5625 equals r squared. And that's actually a perfect square decimal, which is kind of weird. We don't see that a ton. So you get that your radius is 5.25, and then I guess feet in this case here. And that, by the way, is your radius. So then whenever you take your radius right there, I think they're asking for the diameter, so you just need to do double that, so that'll be 10.5. And then you're good to go. As far as a cross section for a sphere, it doesn't really matter where you do it. Any type of plane that you get to intersect a circle, it's going to make, or not a circle, any cross section that you get, or any plane that you get to intersect a sphere will always make a circle no matter where you do it. That is it.